Okay, so today we'll be discussing about the analysis of part of the insertion sort algorithm. Okay, so that means we will try to find out an equation for running time, the whole algorithm, and we will, while doing that, we will try to discuss some other stuff as well related to it. Okay, so if we talk about running time, right, for a particular algorithm, right? So if we talk about running time, so if you we can think of it, it is basically directly proportional to the input size, right? So input size, that means if we have input with larger size, so then that particular algorithm will take more time to execute, right? Now now when we, there are two terms over here, right? One is this guy, input size, right? And another one is running time. Now we have to define these two terms very thoroughly before we proceed. Okay, so let me write it down over here. What do I mean by these two terms? So if I just say input size, okay, input size. Now for different problems, this input size could be different, right? So if I just talk about sorting problem, my input size will be the input array size, right? The length of the input array, right? Now when we talk about multiplication problem, okay, multiplication problem, in that case our input size will be the amount of memory or bits or bytes, whatever we say, to represent the input, right? Correct. Now in our case there could be an input of graph as well, right? So when you talk about algorithms related to graphs, the input could be a graph as well. So in that case we are mainly bothering about how many number of vertices or edges that a graph has, or number of edges that graph has, right? So that means based on the problem we are dealing with, the input size will be changing accordingly, right? So now we just define this input size a bit. Okay, now if we talk about running time here, okay, if we talk about running time, now that means we have to define a procedure by which we can calculate this running time over there, right? Now to generalize all the algorithms, because we'll not be dealing with only the insertion sort algorithm, right? We'll be dealing with merge sorts or bubble sorts, so whatever different kinds of algorithm, right? So that means we need a common ground to define the running time over there, right? So if I just define the total number of time, okay, total time taken to execute all the steps, to execute all the steps all the steps of that algorithm. Now here again another term came, is our steps over here, right? So that means we need a way to define the steps as well, right? Now to define a step we need to understand the pseudocode. That's why if you read a lot of books about algorithm, right? So most of the books use a term called pseudocode, right? So that pseudocode basically defines the steps of the algorithm. So if I just define step here, okay, we can write it down. we can write it down as the each and every line of the pseudocode, right? If I just define a step, pseudocode. Now, let us try to understand the pseudocode for insertion sort first. Okay, then we will see like how to compute the running time over there. Okay, so now if I just go back, if you remember from my previous video, I created for insertion sort algorithm over there. What we did, we started with some array over there, right? And then we apply the algorithm one by one, right? Now where we started from the second position, right? And then next we have done it, right? So that means we'll be starting from the second element of the array, then we will move on. So if I just convert the same logic over here, okay, so that means we will be running a loop. So now in the pseudocode there are two ways you can write a loop. One is a for loop or a while loop. So both the loop works in similar fashion, okay, with a very small difference. Okay, we'll see that one. So if I just write, we'll try to keep a space over here. I'll just write for, I'll just write the loop variable called j. Okay, so j equals to 2, that is where we will start, right? So if I just tell my input array, so if I, there are certain conventions we'll be using it over here. So if I just say a is my input array, okay, it's just a list of numbers over there. Okay, if a is my input array, I'm telling for j equals to 2 to array dot length, right? So this is how we give array length over here, a dot length in the pseudocode. Okay, so that means we are running from, so if I just go back over here, we're running from second element to the length element over there, right? So that is what I have written it over here. Now I'll write it in a separate color now. Okay, so I'll be taking that element, right? Key equals to a j, right? So that means if I just compare it over here, so we are taking 2 first, then we are comparing with rest of the elements we have at the left hand side of the 2. As I told you in previous video, left hand side will be always sorted, as the first element is always sorted, so that's why we are starting with 2, right? And we are comparing with left hand side element. If the 2 is less than this one, then we are moving that element 1 on the right side and then shifting the 2 over there. That is how what we are doing it over here. If you see this, for this 6, we started with this 6, and what we did, the left hand side we compared with 5. Yeah, 5 is greater than 6. If it is there, then only it will be shifting, otherwise it will not be shifting at all. Okay, maybe this is not the best example, I'll take this example of 4, right? So 5 is less than 4, greater than 4, that's why 5 is moving into one position, and 4 is coming between 2 and 4, because 2 is not greater than 4, that's why 2 is not shifting from its position, right? So that is what, like, that means the element we are working with for each and every loop, right? Each and every loop iteration, the element we will be working with, first we will store that element in the key. That is what I have written it over here, aj. Aj means jth element of the array a over there. Okay, so let me change color now again. Now the second line, what we have to do is I have to start another loop over here, right? Because if you see, from that element I have to compare it all other elements before that, right? So that means I have to have another loop, and the loop will start from what position? The current position of the array element before that, just one position before that, right? So I'll do that one now. So I'll say the second loop iteration will be I, right? and from where we will start? We'll start from j minus 1, right? So this is my iterator of the second loop. Now we will have another loop over here. So for that, what I will do is I will take this color. Now I'll say while, so this is another way to write loop over here, I greater than 0. That means I am starting with, if I just again go back to this diagram over here, I'm starting with one element, one position before that one, right? And I will be just doing -1 -1. That means I will be decreasing I continuously. So that's why I am checking I greater than 0, and I will be checking another condition, a of I, right, is greater than key or not. Okay, so basically we are trying to achieve this shifting over here, right? So that means we are checking this guy. Suppose if I take this example of 4, and that's why I'm starting with 5, one position before 4. I'm checking this guy is greater than 4 or not, right? If it is greater than 4, I will be shifting that. So that is logic. We'll be writing it now. So this is the condition. We'll be checking it over here. So if this condition is getting satisfied, what I will do, I will write it down, a I plus 1, that means I am shifting it over here, equals to ai. So this is the code which is basically telling shift to one position right side, right? So here I am shifting. Then what I have to do, I have to write again, let me change the color. So I have to write again I equals to I minus 1, right? Okay, let me go down a bit. Okay, so that means till the point I am getting an element which is greater than my key, I am shifting that one, right? Then when I am not getting that one, that means if I again just go back to this one, so here if you see, first 5 I got which is greater than 4, that's why I'm shifting 5 1. Then I got 2 which is not greater than 4, that means my loop will be breaking over there, right? Because this particular condition will not be satisfied. So that means I'll be coming outside of the loop, right? And when I'll be coming outside of the loop, this I will be automatically decreased as well, because of this condition, because every loop iteration I will be decreasing I, right, after the loop iteration completes. So where I will be placing my key, so that means if I just go back to this 4 again, I have to place my key wherever. So if I just, if you see, the 4 is on third position, right? So I started with I equals to 2, right? If the second position is greater than 4, it is moving to one side. Then I decreased I to I equals to 1 and check 2 which is not greater than 4, right? So it is staying in that position itself, right? Now my I equals to 1 is over here, right? So that means when I'll be breaking my loop, my I will be 1 over here, right? So where I will be placing that 4, I'll be placing that 4 as second position, that means I plus 1 position. So that is what we will be writing it over here now. So I'll write a, okay, I plus 1. This, if you see, I am writing this one with the same indentation as this loop, that means I am outside of the loop over here, equals to key. So that is where I'll be placing my key over here. If you see this whole algorithm, this is the pseudocode of this insertion sort algorithm, where I will be starting with some position, then I will be looping through the left hand side position and check whether that is greater than or not. If it is greater than, I am shifting it by this code, right? Then I am, this code is basically helping this loop to go on. Then when I'll be exiting the loop, the next position, that means on the right side, that's why I am giving the I plus 1 over here, right? I'll be placing that key over there. Okay, now let us try to reason it through, how many times all of these lines will be running. Okay, and we'll be calculating our running time based on that. Okay, so for that what we will do is I'll try to write in separate same color. So if you see how many times this particular line will run. Now if I just say the total size of this array is n, that means there are total n elements over there, right? So we are starting with 2 length, that means we are basically running n minus 1 times this particular line, right? But think about this one. This loop definitely will run n minus 1 times, but when the last time it will run, right, it will again, suppose for the after the last element of this array, when it loop through this one, so when it will run for the last time, it again go back, will check for this condition again, because that condition has to be failed so that it will not go inside the loop again. That means even though we are working on n minus 1 elements over here, this particular line will be running for n times over here because of the last check, right? Because this condition has to be failed, then only it will not go inside the loop, right? Now if we talk about the next line, this line will definitely run for n minus 1 time, because even though when the last, as I said, the same reason, it is checking for this condition, when this condition will be failing, it will not go inside the loop. That means definitely this guy will run for n minus 1 time, right? Even I equals to j minus 1 definitely run for, okay, I'll try to run it in a same color. Okay, this will also run for n minus 1 times, right? Now this guy, this is a condition over here, this is a while loop condition, right? And if you see, this totally depend on the j over there, right? So if I again just go back over here, right, to my PDF. Now when we are in the third position over here, where for 4 it may run for single time, right? For other element it may not run for single time at all, 0 time. For other element it may run for all the elements over there, right? So that means when we talk about j over there, right, so when we talk about this while loop condition, it's totally depends on the j. So if I just denote now another term, let's say I'll just write it down over here with some color. Let's say tj is equals to number of time the this while loop condition execute for each j, right? Because this is something unknown for us. It's totally depends on j and the input array, like how it is sorted, those kind of stuff over there, right? So that means this guy will definitely run for, so for each j it will be running tj, and how many j we are running, from j equals to 2 to array length which is n, right? So that means this yellow guy will run for this many times, right? Now as it happened with the outside loop, now the for the inside guy it will just run is tj minus 1 time every time. So this guy will run, if it is done, if a single time it is running for each and every j, it is running for tj, right? So this guy will definitely run for tj minus 1, and we are running from j equals to 2 to n, right? So hopefully this is clear why this is tj and this is tj minus 1, because the same reason this outside loop condition will be executed one time more, because have it has to calculate this particular condition before it's saying we cannot run this loop again, right? Now similarly this guy this guy will also run for j equals to 2 to n tj minus 1 time, and as this guy is outside the loop and the other guys in this for loop is executed n minus 1 time, so this guy will also execute as n minus 1 time, right? So we determine how many times basically this each and every line of this code will be running, right? So if I just assign a time over there, right, so we know how many times, but if I just know the for each run how much time it took, then it will be easier for us to calculate the whole time this algorithm took, right? So now for that will what I'll define is ci, let's say it's the time taken to run the ith line. Okay, single run of the ith line. So this is my first line. So if I just assign a number over here, I'll just assign this color c1, right? So this is my second line. I'll be saying c2, that means time taken to run the second line. C3, so it will not be same for each and every line because of this internal complexity of the line and how computer handles those stuff, right? And this will be C4, right? For this line it will be C5. For this line it will be C6 and C7, right? Total we have 7 lines, 1 2 3 4 5 6 7 lines, right? So we know how many times it ran, we know for each time what is the time it took, right? So now we can define the total time now, right? I'll just go back over here. So I'll just say this color total time I will denote this as t, as it will be a function of n, right? How many inputs, if you see most of the time over here, because we are dealing with the input of n, right? So it has to be a function of n here, right? So what will my total time? So my total cost will be c1. Okay, I'll just try to write it in a same color. Okay, so c1, then it will be n, correct? c1n plus then c2 into n minus 1, right? So c2 into n minus 1, c2 into n minus 1 plus it will be c3 into n minus 1 again, right? So c3 into n minus 1 plus c4 into this term, right? So that means plus c4 into this big term over here, right? That means summation j equals to 2 to n tj, right? Plus c5 into this term, right? So c5 into this term, that means summation j equals to 2 to n tj minus 1, correct? Plus c6 into this term, right? So that means c6 into, I try to write in the same color, c6 into this guy over here, right? So that means summation j equals to 2 to n tj minus 1, right? Plus c7 into n minus 1, correct? So this is n minus 1. So this will be my total cost over here. Now if you see it over here, this is, if I just simplify it, right? So this will be totally depend on tj, about like what, how it will be as linear one or non-linear one. So for that, let me show you what do I mean by that one. Okay, so now this thing, this tj, because of this tj, we will have two conditions here over here. One is the best case and another is the worst case. If you see it over here, what I am talking about. So I just introduced a new term called, two new term basically, best case, best case and worst case. Okay, best case means this is the case, that means the inputs will be in such a way that the algorithm will take the least amount of time. Worst case means the inputs will be in such a way the algorithm will be taking the most amount of time, right? So for insertion short, what will be our best case scenario here? Our best case scenario will be when our input when our input array will be sorted, will be sorted properly, fully sorted, right? So if I just go back over here, right? So if this guy is fully sorted over there, right, that means the I don't need to do anything over there, right? For each and every j, the left hand portion will be always sorted order. So that means there will be no right hand shifting, nothing, right? And our worst case will be the input array. So input array will be reverse sorted, reverse sorted, right? So if all these array elements are reversely sorted, that means for each and every j, I have to iterate through all the elements of the left hand side of the array, right? So this would be my best case and worst case scenario. Now let us think about what will happen to this tj when we encounter best case scenario and the worst case scenario. Now if you see the best case scenario, that means input array will be already sorted, right? So that means if I just go up over here, okay, if I just go up over here, so that means this condition ai greater than key will always be false, right? This, so if I just compare it with this iteration, if you see it over here, when we picked up 6 over here, right, the left hand portion is already sorted over there, right? So there is no element which is greater than 6, and as left hand portion is always sorted, right? So that means in this case, for each and every j, so if this array, whole array is fully sorted, that means for each and every element this scenario will happen, right? So that means I will no need to iterate, that while loop will not go inside, right? Will not go inside the while loop. Only the while loop conditions will be running single time, right? In that case, that means my tj, so if I just write it down with a similar color, my tj will be 1, right? So in my best case scenario, only these conditions will be running inside portion, nothing will be running over there, right? So now, and what will happen to the worst case scenario? So that means for each and every j, the while loop will run always for all the j values, that means this I values over there, right? So that means in that case my tj will be j, right? Right, tj will be j, because I will be, okay, here I think I have written the I, it has to, sorry, yeah, this is I only. Okay, I was referring to this one. So as I is j minus 1, that means this loop is completely depend on the value of j. And for worst case scenario, as we'll be looping through all the values of j, so that means tj will be j over there, right? Now let us try to compute our cost. talk about time over there when it is a best case scenario or when it's a worst case scenario. So if I just write best case, okay, of n over here, so what will happen, I'll just write it down over here, c1n plus c2 n minus 1, so this thing will not be changing, plus c3 n minus 1 plus this tj, this is 1, right? So that means j equals to 2 to n, that means it is a n minus 1, right? So c4 into n minus 1 plus this guy, if you see tj equals to 1, that means this will become 0, so c5 into 0 plus even this will become 0, c6 into 0 plus c7 into n minus 1, right? So if you see, n has maximum power of 1 over here always, right? So if I just simplify it, you may get something like this, an plus b, right? So where a will be some combination of c1 c2 c3, I'll just not simplify it, okay? So we will be getting a, the n will be not the subscript of n, an plus b. So I'm trying to say it will be a linear equation of n, right, in the best case scenario. Now what will happen in the worst case scenario? So if I just take the value of n over here, so now when tj equals to j, that means we have two terms over here, right? So if I just write it down here, summation j equals to 2 to n j, right? Now this that will be equals to, I think you already know, n to n plus 1 by 2 minus 1. So if you just want me to cover this one, this proofs as well, just let me know, I'll try to prove that one as well. And if I there will be another term called summation j equals to 2 to n j minus 1, because of this term over here, right? So this will be n into n minus 1 over 2, right? So if I just now write this same equation, it will be c1 n plus c2 into n minus 1 plus c3 into n minus 1 plus c4 into this guy will be becoming n into n plus 1 by 2 minus 1, right? So if I just give a bracket over here, now this guy will be plus c5 into this guy, that means n into n minus 1 over 2, right? Plus again c6 will be n, okay, I'll just write in similar way, n into n minus 1 over 2, right? Plus c7 into n minus 1 over here, okay? I'll just go down a bit. If you see, this has to be a in power of 2, right? Because here only we are getting a n square over here, right? So that means we may get a equation something like this, a n square plus bn plus c, if you just simplify it, right? Where a b c will be some combination of c1 c2 c3, right, and c4 dot dot dot. So we got these two things over here. For our best case scenario, it's a linear equation, right? And for our worst case scenario, it's a non-linear equation, right? So basically it's a quadratic equation, right? So that means if we just talk about worst case scenario, this is going to take more time compared to this one, right? So generally when we analyze the algorithm, right, we mainly worried about the worst case scenario, okay? So there is another scenario called average case scenario, where this will be somewhere between like the array will not be properly sorted. Is it like half sorted or half not sorted? So by average, if you see it, like if it's, even though the array will be half sorted, in that case we will be still getting a quadratic equation of n. So that now, so for the average case also we will be getting the similar quadratic equation over there as well, right? So generally that's why sometimes for some algorithm we talk about average case as well, which may be somehow less than the time taken for the worst case algorithm. Now generally when we talk about the algorithm timing or the running time, we generally talk about the worst case. And if you see it over here in this equation, that this term, right, a n square, will be expanding or will be increasing much more compared to these other two terms over here, right? So generally it is expressed as the highest term of this equation over there, okay? And generally the average the algorithm time is written as big theta, okay? So it is somewhere written as something like this, n, okay? And generally it is written as the term of the highest degree, which will be increasing more compared to the other terms. And we also do not consider the coefficient of those term over here, so it will be generally written as n square over here, okay? So this technique is generally called order of order of growth, right? So that means the higher order will be, the higher more time it will take to execute the algorithm, okay? So for our insertion sort, we are getting the algorithm growth rate as n square over here, which is a quadratic in nature, okay? So in future videos we'll see also how for other algorithms what is the value we are getting over here, okay? And we also discuss like what are the different approaches we'll follow for algorithm, okay? Different scenarios, what is the different approaches we should follow to construct an algorithm, proper algorithm for that scenario, okay? Hopefully this video is helpful. See you in next video.